Geotechnical Engineering, Part A, Soil Mechanics, Chapter 8, Seepage. We want to continue to solve a problem consisting of a soil with two layers, soil 1 and soil 2, with a one-dimensional seepage in z direction. If you remember last time we just solved it and we reached to a 4 equations and a 4 unknown. When we solve these 4 equations simultaneously, we get these four coefficients of C1 through C4. And as soon as we have C1 through C4, we can replace that in H, water head equation, and also U, water pressure equation, to get H and water pressure, also head of water and water pressure. If we want to solve it in a simpler approach, this time we just modify the solution to eliminate 2 equations. So we just, this time in solution 2, which is easier than the previous solution, we just solved it by a system consisting of 2 equations and 2 unknowns. And definitely our 2 unknowns are delta H1 and delta H2. Delta H1 is the amount of water which delta H1 water get tired from passing through beginning of soil 1 and then passes through soil 1 and reaches to interface. There is a drop off head by delta H1, and then from the interface of two soil, this is soil 2, to the end of soil 2 we have delta H2. Combination of them should be equal to total head of water, which is equal to the head of water, the difference between the highest maximum water and so minimum of water. So 0.6, 0.35, 0.25, which if you add them up together, they are equal to delta H1 plus delta H2. Total head loss is difference between highest water level to the lowest water level. That's delta H1 plus delta H2. The summation of them is equal to 1.2. That's our first equation. And then we do know the same amount of water passes through both soils. So, and Q is KIA. If we K1, I1, A1, area 1 is equal to area 2 based off problem statement, we can cancel that. That's 2 K2 I2. K1 I1 is equal to K2 I2. That's our second equation. If we just solve these 2 equations simultaneously, we can get the answer. So as you can see here, the total head delta HT at the top is 1.2. As you travel between soil 1, there is a head loss H delta H1, and when you travel between second soil, a linear drop to HD, which is 0. And if you just remember total head at D, this is our base line. There is this much amount of water, so that's 0.1 positive 1 of water pressure. And if you just climb down this much from the same amount right from base, that's a climbing down. It just gives us a delta H at D. H at D is equal to 0, as you can see here as well. So as you can see, the maximum head loss to the minimum loss, which is 0. We just replaced K1 by K1 is provided 10 to negative 5 delta H1 over delta L1. Length of first soil is from here to here, which is to 0.4 meters. As you can see here, the length of soil 1 is 0.4 meters. Delta H1 over delta L1, it just means how much drop can you find when you travel from the beginning of soil 1 to the interface of both soils over the length of delta. Same story for the second layer of soil delta H2 over the length of second soil, which is 0.3, and it just gives us a relation between, makes a bit clear. If you just solve it for getting the equation, it just gives us a relation between delta H1 and delta H2, which delta H1 is 3.34 delta H2. This is our second equation. These two are identical. This is the parametric. This is the relation between them. If we just have equation 1, the total head loss is 1, 2, like as you can see here at the top, and that summation of 0.6, 0.35, 0.25, and the second one is the ratio of these two. Combining these two equations, it just gives us a delta H2. H2 is 0.2765, and also delta H1 equal to 0.9235. And if you add these two up, you can get 1 point, which is the total head loss. As soon as we have delta H1 and delta H2, so this is our delta H1 and this is delta H2. So between relation of this triangle, this similar triangle, 0.9235 to 0.4, this is 0.4, is equal to x over 0.35, because this height is 0.35. You can easily get the numeric value for x, and these are the same lines, so you can easily get the amount of, if you subtract x minus 1.2 or 1. Hxx is 1 point minus 0.808, because this is a triangle and these two are equal. 1.2 minus xx give us the head of xx line, that's 0.392. As soon as you have the head of water, you is hxx minus zxx times gamma of w, and it just gives us 1 kilonewton over meter squared, which is the same answer in solution 1. Thank you. We can solve it yet an easier approach, which I'm going to present it in next video. Thank you.